Hello and welcome back to compiler programming. In the last video I took care of if, and in this one I will tackle another important primitive, which is a loop. But the way I'm gonna approach this is a bit different maybe from the languages that you're used to. In fact, I will do something that is actually possible in C but nobody really uses. And the way this would work is, in general, a loop is just the following. You have, so let me rename the test file, remember, parse and run. Actually, no, I will not put here anything because we'll see why in a second. So the loop actually looks like this. So you have a label, right? Then you have a body of the loop. So for example, I would do printf like this. And then I would say that go to loop. This is how loop looks like in assembly, and you can write it the same way in C. So this will be an infinite loop, right? So it just constantly repeats printf. And if you want to have a while loop, then you would put an if statement over here. So if you say if, I don't know, I is less than 10, whatever, right, then you do this. Otherwise, you go to loop end, and here's your loop end. Actually, I probably don't need this stuff. Right, so this would be a while loop. If I want to have sort of do while loop, I would put this here, I guess, and then I don't really need this one. So I would just actually, in case of while loop, I also don't need that one technically. Yeah, probably like this would also work in case of a while loop. And then for do while, we just move the condition to be after the body. And for loop is just syntactic sugar that allows you to put a statement basically over here and jump to it. So there is nothing really much. The loop end is necessary in case you want to have a break statement. So if I have a while with a break, then I would, that break essentially means go to here, right? So for this language, I want to eventually have a very nice macro support, and I want while loops and all kinds of loops, to be honest, to just be macros. Because as you can see, they are assemblable from these raw pieces of, like, I have labels, I have blocks, and I have some code that I can use. So that means that we should be able to do it that way as well. Now, the syntax of it is going to be rather interesting. Right now, I'm using a colon for defining a variable, right? So I just declare declaring a variable and then doing something. So like I would say something like x is s64, right? I'm declaring x to be 64, but I'm not providing values. This is what a single colon is used for, and so I can't use it for labels, probably. Now, I might be able to somehow make it work. Like I could say something like this. This might be an option, and then label is a special keyword that just provides a clue to this operation to do something different. That might be an option. It might be probably the easiest option and what I'm going for, but there could also be other ways we could do it. But it's not really important because syntax I deliberately want to make syntax very easy to change, so I can later figure out what I want to do with it. So let's say we go for this option. So we say X is a label, and that does something specific. And then we do the regular stuff. So loop, and what do I want to do? Well, I guess let's say count to 10, right? Or maybe this is a bit more useful function, sum up to, right? So we provide a number to it, and it will sum the numbers up to that amount. Okay, so how that look like? Well, we say that sum is going to be 0, and actually right now I will probably have to do it like this. So say that it's S32, and I don't support this form yet, but we will at some point. So I will have to spread it across 2 statements: first declaration, then assignment, or I can do a fancier algorithm and just say we are starting with X, and then we will count down from to 0. Or if X will be negative, then we have a problem, but I guess that's fine. Okay. So we create a label, then we need to have well, we don't even need the block generally, so we can just straight up do this. Like even in here, it's also a block is not necessary. Like I could do this stuff, right? And this is perfectly functional. So let's continue this. We say loop is a label. Maybe I want to do it like this. I don't know. Yeah, maybe this is better option. And what now? Well, we need to do the actual comparison. So we say if X is less than 0, then do what? Well, then return sum, right? And otherwise, we say that X is X minus 1. Well, actually, yeah, this is a bit unfortunate. I do have to spread it like this, but it's fine. So I'm basically doing a for loop here, which looks a bit strange, but it is a for loop, believe me. Okay, so I say that sum is sum plus X, and then I say that X is X minus 1, which we also don't support at the moment. In fact, this will break horribly. So I have to do it like this at the moment, which is a bit unfortunate, but it's fine. And then we say go to loop. So that's quite a bit more complicated than majority of the programs that we have dealt till now, but that is fine. So sum up to is gonna be like this, like this, like this, and let's add some tests. We say sum up to 0. Actually, we also should have less or equal to 0. Well, Actually, it doesn't really matter. We will do an extra operation, but it doesn't matter. So this is fine. Sum is 1. Sum up to 1 should be 1. And 2 is 3, right? And 3 is 6. So something like that. Okay. Obviously, this will not really work because we have a program with labels and GOTO. So we don't have labels, we don't have GOTO. So yeah, all of that is not gonna be good. Well, let's still run the test and see where exactly we'll fail. In general, I try to do the assertion-based stuff. So let's see if that works. So this is the return type. I think that is being unhappy. Let's try that. Okay. Here actually this should be S32 to S32. Not that it matters for our samples, but it should be. So same value type, function line 396. So go to 396. And this is plus or minus. And you are unhappy. You are unhappy about this stuff. So how do I want to deal with this? Guess let's do it correctly. There is this, I don't remember how I called it, but something about curseable. Yeah, same value type or can implicitly move cast. So something like that. And here we will need to do the same thing as was happening with the compare. So I think eventually I will need to extract this stuff into some kind of helper, but I prefer to do it only after I understand the exact requirements for that. So we have larger descriptor. We used that here. And the rest should be fine. Okay, let's see if we can continue forward. Could not reduce the expression. That is most likely happening over here. So maybe I should actually print out at least the line where that happens. So yeah. So what I will do is I will say that token star token is state tokens, and then I make array get of state tokens 0, and I will do printf I basically do the same thing. Add line and then percent u, I think it is u64, and say token location line or something like this. Location is not a member of token. Apparently I don't remember my own struct. Token, it's probably inside of here. Token, yeah, it's called, no, this is source. Yeah, so apparently, don't I track this? So maybe I don't. How do I do print message with location? So source location, source location. This is just part of tokenizer, but it's not part of the token. Token just has a slice. Well, whatever. We'll deal with it later. For now, I will just print the slice. Register expression, and I'll just say -n, and then slice print token source. Yeah, I need to have start here. Let's check. Yeah, so I was correct. It is GOTO that was failing. Obviously, errors can be improved dramatically, but we got the most important piece of information here. So let's deal with GOTO. GOTO is also a statement. So we say token rewrite GOTO. I will use maybe if as an example. Let's take that. Let's take rewrite GOTO, and GOTO should work as follows. It should be a keyword GOTO, and then I actually expect an identifier. It couldn't be an arbitrary expression. It literally needs to be an identifier. And that actually might cause an issue. Let's see. Maybe I'm overthinking this. Good. We need to do something here. So the actual logic, and that actual logic we can look up inside of if, I guess. So define if. This is it not in this file? I moved it to the header. So let's do it here. If builder, make if should be back in here. I'm just checking out what's happening. So we'll need to do something like that. Actually, label stuff will probably need to change. Right now it's a separate thing. It's not a value. And I think it needs to become a regular value that is just called label, or the value will not have type. I don't know. We'll see. Anyhow, we are just doing JC jump. So there is no wrapper on this, but that's fine. I can do jump directly. So we need to look up. So I need to say label star label is something, right? And then we do jump label 32, and we say label. So here, let me just put 0 for now to check the rest. Builder is undeclared. Okay. So this needs to be 2. Okay. So the question is, where do we get the label? Well, the label, according to our test, should come from this definition. But for now, it is it's not gonna work. I mean, we can say that value star value is scope lookup force of scope and then I say that's not a condition. This is called label ID something. Or label name, that's also fine. Label name source. Too few arguments per call. I think it also needs to have a builder because it might need to write some stuff. Can I convert function builder to slice? So it is other way around. I misjudged the arguments. Okay, here's still 0. And we need to do something with that value. But it will fall apart right here because we need to figure out how we're gonna store the labels in the system. And right now, these are the descriptor types, and then these are the operands. No, this is encoding type. Where are operands? These are operands. So we have a label operand, but we don't have a label descriptor. So I guess I can just shove void in there and call it a day for now, and maybe that's even okay. Yeah, let's maybe do that. So that means we need to add another thing into here where I say that we have a rewrite, and we rewrite label. Doesn't matter which one we take. We have this thing. We say rewrite label. It matches well, probably something from the if is easier, so something like this, right? We just match the keyword label, and we create a value. So we say temp allocate value, and value is the following. We have type, which is descriptor type void, and then we have operand, which is a label. I think there is like a make label. Yeah, so I just do make label 32. Okay, that sounds good. Label 32 of make label. And then I make a value. Replacement is just this single thing. That sounds good. Let's see what is gonna happen. It's not a type, it's a descriptor. And here I need to say, I need to allocate the descriptor as well. So descriptors are, actually for void, I can probably say descriptor void. Okay, plus token is undefined, that's fine. We will say keyword. Okay, so we have successfully replaced it with the right thing. So we do have a label. It is even should be created at the right location, I think. How do I... No, I think we need to do something else, right? We need to have this push instruction. Where do we create a label? Yeah, so this needs to happen. I'm just thinking at which point does it need to happen? Maybe, it needs to... So yeah, right now I'm gonna start running into limitations of the approach I took with the parsing here, because everything is sort of done out of order, and that also to a degree applies to the instructions themselves that we are dealing with. Let me think about how to handle this. I think I will change the syntax here to do this, and then and then here we'll do some fancy stuff. Actually, this is not required anymore. And now I can say that if type is token type ID, then we do whatever we were doing before. That is fine. Else we do the following. We say value star value is token force value of type. And then I want to assert that value descriptor type is descriptor type void, and then I also want to assert that value operand type is operand type label 32, and then I can extract the actual label. Yeah, label star label. Oh, I might not need the label. I just need to push the instruction with it. So I say that value operand type operand label 32 label, something like that. Okay, that's a lot of issues. Let's deal with them one by one. That is fine. Here I need more parameters, so I think it's type scope builder or something. And here I need to have arrows, I think. Value operand term does not evaluate function. Yeah. Here actually it is dot operand type. Maybe it's just label. No, what was the name of it? Operand type. Operand type. Where are you? It's label underscore 32. Okay. Builder undeclared identifier. That's fine. And it's not a member of label. Label 32. Going back to here. So this is just like this. Good. So that should successfully mark the right place for the instruction. So like we will point the label to the right position here. This just should work. That's okay. And then the rest is what? The remaining stuff that we need to do here is we need to do this thing. So we looked it up. we need to essentially assert the same thing. So something like this. I will just take that stuff from here, and we can do here, instead of this push instruction, I can just say value operand label. Actually, I don't need to wrap it again. This will be just like this value operand. Okay, that's a lot of typing without running the program, so let's see how terribly we run and crash. Assertion failed entry. Assert entry. So let's do a bit more debugging here, debug information. So we say could not resolve identifier, and then I will say slice print name, and then I would say here /n. Okay. Whoa. And that should happen like this. I should say if not entry, then do this resolution. Could not resolve identifier loop. That is probably because I did not do the right thing over here. Yeah. We still need to do this. So let's say that value, and we put it over here and say this is 0. In this case, we reserve stack. Otherwise, we do this. Okay. And that's amazing. So apparently everything works as expected. Obviously, there is still lots of things to clean up. Like, this is not elegant. This is definitely not something that is good long term, but both of those are problems for some other day. For now, the most important thing is we have labels and we have GOTO, which means that whenever I'm ready to start working in macros, we can have very nice loops. That would be it for today. Thank you very much for watching, and hopefully see you next time.